In this video, let's try to understand how can we actually implement the get operation on a singly linked list. So the main purpose of get functionality on a singly linked list is to retrieve the node that is available at a specific index. So as part of this get functionality implementation, what exactly we request from the user is basically the index. Index is nothing but the position at which the node is requested by the user. So first, let's try to understand how the indexes actually work in the case of singly linked list. So it is not a complicated thing. If you happen to know arrays concept, right? We know in the arrays the index starts from 0 and ends at the length of the array minus 1. Similarly, in the case of singly linked list also, the index will start from 0 and ends at length of the linked list minus 1. So if I have to add the indexes to the nodes that we have inside the singly linked list, right? Let's try to do it on a sample linked list that we can see here. So here we have a singly linked list containing 6 values in it. So obviously the starting index will be 0 and the ending index will be length of the linked list minus 1, that is 5. So here the very first node, that is 10, will be available at index 0. Similarly, the node with the value code will be available at index 1. Similarly, the node with the value true we have at index 2. Similarly, all other nodes also we can give the index value. So as part of the get operation, if the user passes a certain index, right, we have to return the node that is available at that particular index. So we are expecting the index value also from the user from 0 till the length of the linked list minus 1 as part of the argument. So that is how we actually represent the indexes in the case of singly linked list as well. Now let's go ahead and let's try to understand what all are the different cases that could possibly come when we try to implement the get functionality. So let's just try to understand the different cases. Obviously here we are taking the index as an argument from the user, right? So user might not be aware of the length of the linked list and can give the index that is beyond the maximum possible index or any negative value as well. So we have to handle those cases as well. So as part of the first case, let's try to handle invalid indexes. So the minimum possible index is 0 and the maximum possible index will be length of the linked list minus 1. So any negative values or any values beyond length of the linked list minus 1 are actually invalid indexes because the nodes that are available are at index 0 till the length of the linked list minus 1 only. So if any other value comes, first what we have to do is we have to simply return null or none based on our choice of programming language. If you are using Python based programming language, you will simply return none in that case because user has passed some invalid index that could be negative index or it could be the index that is not in the range of whatever the indexes that we have in the singly linked list. That is the case where we handle the invalid indexes. If the second case is actually the valid indexes given by the user. So if the user has actually given the valid index, right? So our job is to start at the head node and we have to go to the node that is given by the user at that particular index and we have to return the entire node here. Okay, we are not simply returning the value we have in the node, rather we are returning the complete node. Okay, why? Because we can reuse this get functionality in the future operations such as set, insert, delete, and all these functionalities we can reuse this get functionality. That's why we make sure that we are returning the entire node object but not the value. Okay, so how will we actually do that, right? So let's assume that the index that user has given is, let's say, 3. So that means that my program should return the node that is available at index 3. That means I should return the node test as a output. So what exactly I will do is I will start traversing the linked list at the head node, because in the single linked list that I'm implementing, I have the access to the head node, I have the access to the tail node, I have access to the length of the linked list. Now, since I have the head node, I can start traversing at head node. From head, I can go to the next node, right? Because each and every node has the reference of the next node. That means if I go to the next node, I will be at index 1, which is not the index that user has requested. So on index 1, I will again read the next node. I will go on to the index true, right? Now this is at index 2. That is not the index that user has requested. User has requested the node at index 3. So again, from the next that we have on the node true, I will go on to the node with the value test. Now my index is 3. So I can simply return the node with the value test as a output here. Okay, so for going to the index that is available at a given index, we will simply be running a loop. How will I exactly run the loop? That I will show you when I write the pseudocode as well as the programmatic implementation. But this is how, this is the overview of how we can implement the get functionality based on the index that user is passing. Okay, now that we have understood the different scenarios that could arise while implementing the get functionality, right? Let's try to write the pseudocode for implementing the get functionality as well. So here what we will do, we will simply write a function called get, and here we will be taking the index from the user. So when we discuss the algorithm, right, what exactly we discussed? There will be two checks. The first check is to check if index is invalid. So how will we check if the index is invalid? Internally in the singly linked list representation, we are keeping track of the length of the linked list. That means we know the minimum range is 0 and the maximum range is length minus 1. If at all, if the user is, whatever the index that user is passing, if it is less than 0 or greater than or equal to the length, that means that is a invalid index. Based on that invalid index, if the user is giving, right, obviously we will not have the node at that particular index, so we will simply return null or none based on our programmatic implementation. If we are using Python, we will simply return null, none. If we use JavaScript or Java based representation, we will simply return null here. Okay, so this is the case if the index is invalid. Okay, as part of the next scenario, we have to handle the valid indexes. So anything that is not falling onto above range, that is if the index is falling in the range of 0 till the length of the linked list minus 1, that user has given a valid index. Now here what we have to do is, I will simply define a variable called current node, and I have the access to the head node, right? I will simply assign head node to it. Similarly, I will define one variable like counter and I will initialize it with 0, because right now the node that I'm processing is at the very first node, right? Let's assume that I have a singly linked list containing, let's say, 4 values. Let's say 10 code, let's say true and false. The index that user has given is 3. Let's assume 0, 1, 2, 3. This is the head node, this is the tail node. Since I am starting at the head node, right, the counter I am initializing it with 0. Now what I will do is, I will simply run a loop while this counter is not equal to the index that user has given. That means that I am not at the index that user has passed. Inside this while loop, what we can do, we can simply, we have the node reference. On the node we have the next available, right? So we will simply update current node variable with current node dot next. In that way we are simply moving on to the next nodes, and since we are moving on to the next node, the counter should be incremented by 1. So counter should be counter plus 1. Once we go to the index that is given by the user, right, the current node will be available at that index, and the current node variable, whatever we are using, will be having the reference of the node that is available at that particular index. So we will simply break out of this loop. In the end, we will simply return the current node. Okay, this is how we exactly write the pseudocode for implementing the get functionality on a singly linked list. Now let's quickly write the get operation implementation on the singly linked list quickly, and let's move on to the next operations. So here, as part of the get operation, what we will do, we will basically take the index of the node that we want to get in the singly linked list that we have, and we need to return the node that is available at that specific position that is given by the user. So in the end, we need to return the node. That's the reason why the function's return type will be node, and let's just name the function as get, and what it does, it will basically take the index from the user. Now remember that the way this index works is exactly similar to what we have in the case of arrays. In the case of arrays, the index starts from 0 and ends at length of the array -1, right? Here also the index value follows the similar pattern. So whenever we are taking this index from the user, right, there is a very good chance that user might give some invalid values for this index. As a result, at that specific position the node might not be available. So what are those values? Basically, we are already keeping track of the length. So the possible values for the index are from 0 till length of the linked list -1. Any value that is going beyond this one are invalid indexes. So first let's write the logic for returning the null value if the user passes an invalid index. So if at all, if the index that is given by the user, if it is less than 0, or if at all the index given by the user is greater than or equal to the largest index that we have, that is nothing but the largest index that we have is length of the linked list -1. Any value that is beyond that is a invalid index. So we are putting the next check here. As long as the value that is given by the user is in the range, that means from 0 till the length of the linked list -1, they are a valid values, and we will have the nodes at that specific position. So if this index falls into this range, it is an invalid index, so we've written null. Otherwise, what we need to do, we need to go to the node that is available at this specific index, right? So let me just define one temporary variable I, and let me just initialize it with 0, and let me just start going to that specific node at that specific position from the head node. So let me just define the node. So let me just name it as current node equal to this dot head. Once we have the head node, what we can do, we can simply run a loop as long as the value of the index that is given by the user is not equal to this I that we are keeping track of. So if the index is not equal to I, whatever we are keeping track of, what we need to do, we simply need to move on to the next node. So current node, let's just update with current node dot next. Since we have moved on to the next node, whatever the counter that we are keeping track of, this also let's just increment by 1. Okay, so as we increment the I by 1 and move on to the next node till this index, okay, once we reach a point where this I becomes equal to index that is given by the user, right, this condition will not match and we will break out of the loop, and whatever the node that we have inside this current node will be pointing to the node that is at this specific index. So we can simply return the current node. Okay, so that is the implementation of the get operation. Remember that whenever we are taking the index from the user can pass invalid indexes. So as part of the first check, we've eliminated all those invalid indexes, and as part of the otherwise, if the user passes a valid index, we are keeping track of a local counter, and we are running a loop as long as that counter is not equal to the index that is given by the user, and we are simply moving on to the next node till we reach that specific index. Once we reach there, we are returning that specific node. Okay, so that is the get operation implementation. Now we can call this function and validate on the singly linked list that we have. So let me just comment out all these shift calls and traverse calls and all those things. These things we don't need now. Here now let's just do SLL dot get. Right now we have 3 values in the singly linked list, right? So the possible valid values for the index are from 0 to 2. So if I pass any value beyond that, let's just say I pass the value 3. So it is an invalid index, right? So ideally I should be getting null as it is an invalid index. So one thing that we can do is we can simply capture that value and print that too. So let's just cap, it returns the node. So let me just read the node object, and here let me just do cout of to print the null. Let me just do node equal to null, so that we will basically see 1 on the console, indicating that it is a null value. So if I run this code, ideally it should return null. Let's see. Okay, here the type we have already mentioned, right? It is going to store the integers. As a result, here also we need to mention the int only, because as the singly linked list contains only integer values, the node that will be returned by the get functionality also will be of type int. So we need to mention that type here, and I missed that. As a result, it slapped me on my face, and now I'm correcting it. Okay, here I have missed one more pair here. Now if I run this once again, see, as part of the traverse we have printed these 3 values. Since we have passed an invalid index, immediately it returned null. As a result, as part of this comparison we have printed 1. Okay, if I pass a valid index, I need to get the node at the second position, which is nothing but this -10. Remember that as part of the get functionality, we will get the node. We will not delete or modify or anything like that. That is something that we need to remember. So obviously, the node that we are getting will be not null, right? So ideally, the value that you should see should be 0, indicating false. So 0 is something that we have seen. Anyway, it is a valid node, right? On this node also, we will have the value, since it is a singly linked list node, right? And the node at the second position basically has the value -10. So if I try to print the node.value, that is what we should print on the screen. So if I run code, see, we've got -10. -10 is the value at index 2. Why? Index 0 has 0, index 1 has 10, index 2 has -10. Similarly, if I pass index 1, right, index 1 has 10, so it should return that one. See, we've got 10 on the console. So our get operation is also working absolutely fine for all the scenarios that we have discussed here. Okay, so that's it for this one. In the next operation, we will work on updating the specific node at a specific position, which is nothing but set operation on a singly linked list. But remember that we will be reusing the get operation there. So be clear about this get operation implementation. If at all, if you have any doubts, just try to rewatch it, or you can go to the codingpal.org's visualization panel. For every function, whatever we have implemented so far, you can go there and you can visualize it to get the better clarity as well. Even after that, if you still have doubts, you can post that question in the comment section, and we will get through. I will try my level best to explain the doubt that you have. Okay, now that we have implemented the get functionality on a singly linked list, let's just try to understand the time complexity and space complexity involved in the implementation process. And both these also, let's just try to understand in terms of best case scenario as well as in the worst case scenario. So when will the best case scenario of get operation will actually occur? Whenever the index that user is passing, if it is equal to 0. That means that, let's assume that our singly linked list contains some number of nodes, right? And we have the head node and we have the tail node. When the user passes an index 0, whatever the iteration logic that we are executing for reaching the node at that particular index, right, that will not even get executed. We will simply return the current node immediately. So obviously, since we are not running the loop, the time complexity will be order of 1 in the best case scenario that occurs when the index that is given by the user is 0. Now, when will the worst case scenario will actually appear, right? Let's assume that the singly linked list on which we are trying to perform the get operation has n number of nodes. So the worst case scenario will actually appear when we are trying to read the or get the value that is available at the very last index. That is, the index that user passed is equal to length of the linked list minus 1. In that case, we will have to start traversing at the head node, and one by one node using the next references we have to reach the very last node. That's why whatever the iteration logic that we are writing, right, it will get executed for n number of times. As a result, the worst case time complexity will be order of n in worst case scenario, where the index given by the user is n minus 1, and in the best case scenario the index that is given by the user is 0, and the loop will not get executed, and the time complexity will be order of 1. Now that is in terms of time complexity. Now let's just try to understand in terms of space complexity. Be it best case or worst case, what exactly we are doing inside, even if we execute the iteration logic that we are writing for getting the node, right, there we have basically defined two variables. One is to keep track of current node that we are processing, and the other is a variable called counter, which keeps count of how many number of times we are iterated. Basically it keeps track of, if the index is matching with the index that user has passed, right? And we know these two variables will take constant amount of memory. So obviously, even if it is the best case or worst case, same variables will be reused. As a result, be it best case scenario or be it worst case scenario, the space complexity will be order of 1 only. Why? Because we are simply using the same current node and counter variables for keeping track of the next node that we are processing, and the index that we are currently processing. Okay, so that is the way we calculate the time complexity and space complexity for get operation on a singly linked list. Okay, in the next video we will see how can we reuse this get functionality for implementing the set functionality on a singly linked list. Okay, I'll see you there.